Thank you for spending your Boxing Day morning with us. I know it's a day after Christmas. Um, it's a morning workshop, so thank you for joining us, and thank you, Dr. Yong, for agreeing to teach. Glad to see everyone awake and here in the morning. Um, so, without further ado, I'll pass it on to our trainer, Dr. Yong Poh Yu. Take over for the day.
Hello, my test. Can you hear me?
Yep, all good.
Is my voice clear enough?
Yep, okay.
Okay, so good morning, ladies and gentlemen. Good morning, students. I assume that all of you are students, right? Okay, so first of all, to have to break the ice, a quick one here. So just yes, some of you tell me, okay, it's nice. So as usual, if anything, right, you treat this as more like a so-called what's it, just a conversation, a casual talk, rather than the formal lecture class that you must sit there and then quietly listen or whatever, turn on the what's it, a computer, but then just a sit beside or what it is. Okay, this is a casual talk whereby you can talk to me, you can stop me anytime to just ask any question. Either you type it there or else raise your hand or even directly turn on your mic and stop me for a while to ask whatever the questions that you want to ask or you are not clear, okay, for the next this 2 hours talk here. Okay, and then allow me to introduce I myself. This is you. Okay, so that you can, there was an old joke about you can call me you, I'm you, but you are not me. Okay, because I'm really you. Okay, I believe that you can always remember me. So before this, right, I was with academy as well for many years. Okay, I was in charge of the postgraduate programs, okay, dealing with all those industry projects and so on. So that because my mindset was also called teaching philosophy, right? It's not just to make sure that students understand the theories and also so-called the tutorial practical and so on, but this kind of practical knowledge, right, must be applicable to the industry whereby the students, right, especially upon graduation, right, they already have the mindset, they already have the skill set as well, how to survive in the industry or corporate once they when go out working. That is the part that I always wish to do. And for those who are interested to join me, right, I mean, what's that, you feel free to try my this one. Okay, just a while I open it. This is my LinkedIn. I just send you through the message box there or the chat room there. You may just add me or follow me because from time to time I will always share my experience as well as some whatever the projects I did and so on, and then publish it through the GitHub and so on everything. Okay, so let me start the journey now. But before that, right, to understand you better, I will ask a couple of questions here. Perhaps let me share my screen. Can you see my screen? Yes, sir. That's nice. Okay, so I would like to check a bit with you here. So first of all, I just use this poll. Oops. Oh, only host can do it. Okay, that is fine. Okay, I just use a quick one the way. Okay, indeed I wish to use this feature, but it's okay. Okay, due to the I think it's a license problem, right? Okay, anyhow, let me ask you. If you think that you have a very strong so-called what's it, the knowledge and also experience in using Python, please raise your hand. Just raise your hand, easy one. Okay, a couple of you. Okay, so if you think that you are very okay, please put down your hand. Thank you very much. If you think that you are very weak in Python, please raise your hand. Nobody here. Okay, a few. Shall I say that you are humble or okay? And then the next question, right? If you know OOP, object-oriented programming, please raise your hand. Quite a few. Looks like the same name as well. Okay, that's very good. Okay, please put down your hand. Thank you very much. Okay, the last question right here. If you know machine learning, please raise your hand. Okay, Daniel as well. Okay, who else? That means as a relatively machine learning, this part right, you all have a less exposure, right? Okay. So thank you for the organizer to create this pool so that normally, right, if I have access right, or authority right, I will already create all this thing and then put it to discuss together. So you all can fill in so that I have the because we are talking about data analytics, we're talking about machine learning, so that normally even for the teaching, right, try to also say that use this the facility here to create the data analytics as well for teaching learning purpose. Okay, to have a better teaching and learning situation also called the process here. Okay, so that's fine. So the next right, I would like you to go to this one. Let me copy and paste the entire link here. This is the material that we are going to use today, more, probably the second hour. The first hour, right, more like a sharing with you the regarding the machine learning. Okay, and again, I would like to thank the organizer for inviting me this one to join here and then to share the knowledge with you. Despite that today is a Sunday and also after Christmas, right? Just a second day only. So again, I will wish to the organizer as well as the participants here Merry Christmas and Happy New Year. On the other hand, also for those who are not celebrating, Happy weekend, Happy holiday. Okay, so please make sure that you access this GitHub successfully. So that may I know again who have a GitHub? Please raise your hand. Okay, that's great. Also, quite a number of you. Okay, thank you very much. So that you can again focus or else just follow my one here, watch and what so on. So that to have this because today I'm going to discuss this one with you, and you can see everything right is already inside the whole things about the machine learning. But of course, it's in Python, so it's very easy for you to pick up. Okay, and the last question I wish to ask before I continue it here: have you ever heard this term? We call it collab. Google Collet, please raise your hand. Okay, that's very good. Wait, a few only, which means the rest no experience, right? Okay, then I will start from scratch. Before that, right, let me introduce you a little bit theory with you. Okay, so again, the ladies and gentlemen, students are here, right? What you need to do is just that you go to the post here, please fill in accordingly, vote it accordingly, so that I have a better understanding. Okay, again, this kind of data analytics is important for the organizer as well as I myself to understand you better. Okay, thanks to this Google Meet, it actually has all these feature. Okay, then the next writer, I would like to open this whiteboard. I don't really give you any slideshow and so on. Okay, because again today is a more for practical, right? And also for the slideshow, right? I think it's better I just scribble something and let you understand. Okay. I just put it this one, but then you do not edit it, okay? Because again, due to the this one, the license and also access authority, right? I can only share to four. I think it's unfair. I directly turn on everything. Okay, you can just enter this link, but do not edit anything. You just log in only. Okay. First of all, we have this one, right? I believe that you all have heard it the moment this. Sometimes we just call it data. Then you might have heard also machine learning. By the way, because I'm writing on the screen, please allow me to turn off my video. Okay, I don't think you need to see my face as well. Okay, the reason is that right now actually I'm at kampong. Okay, I bought a kampong already so that I need to save the resources as well. Okay, artificial intelligence. Double check. I'm sharing my screen. Okay. Yeah. Okay. So you have this street. Wednesday, the people are talking about this street. I just want to read that how it actually work. So called practically. So it's just like the human. When we say we want to do the machine learning or whatsoever, you can try to think that it's just a human. Like example, I have a doctor, I have a kid. I always teach my kid that okay, let's say to know what is cat, what is dog. So I use a couple of fresh cut. I said, a girl, this is cat, a boy, this is dog. So normally we have the materials for the human learning process. So by all means, human will start learning and experience the human learning. And from that, right, after a couple of the moment, my kids, right, start to learn all the things that when he or she, right, went to the park or whatever, right, then she could tell me that, Papa, this is a cat, this is a dog, and so on. And by the time that we said that, okay, they all have gained the human intelligence, just like you all as well. Okay, the materials like tutorial whatsoever, GitHub and so on, you all learn through the class and also your self-learning and so on. And after that, right, you get your human intelligence, and then you can graduate. Once you can graduate, right, of course, that's a good thing. Of course, for human, right, as students, right, you can graduate with a good CGPA, with a good working, what's that, so-called knowledge and also skill set. Now we move to the machine. With that, right, of course, the machine here, right, we must feed them the suitable data, okay, sufficient data, appropriate data, and so on, so the machine can start learning it. And after a moment whereby the machine already complete the learning, right, the machine gains is artificial intelligence. And therefore, similarly, if a student is graduate, right, then we will say that for artificial intelligence here is that we can deploy it. We can deploy it as a full solution, either as a the simplest way is a exe file, executable file, or else later we can also deploy it as a on the cloud. Okay, the next question I hear: have you ever heard cloud solution or cloud computing whatsoever? Please raise your hand. Anyone? Okay, thank you. A few of you. Okay, the next question: how about have you ever deployed any project or whatever to the cloud so that you have your own web application? Share the link. Please raise your hand. This one nobody, okay. So that's good that you have heard the cloud and so on. But remember one thing here is that you must also that towards so-called the upon graduation, it will be good that if you really learn it how to deploy to the cloud. Doesn't matter those so-called more for enterprise cloud, like example Google, GCP, Microsoft Azure, AWS. I believe that especially like AWS, right? Amazon, the AWS actually provide a lot of freebie for students. Okay, and then also some of you might have heard of Huawei, Alibaba, and so on. And also there are also some other more for the slightly smaller scale, like example Heroku, and so on. Okay, this is the part that in general we should know this as well. Whereas, right, today the target here is more about this machine learning, and this machine learning, basically, let me tell you, generally, it's just a modeling. It has a few parts here, okay, but generally, it's just a modeling. And with that, right, you must understand that this whole thing, right, in the end, right, no matter how it deal with data, the data is the most important. And when we say data science, and nowadays I think data science are very popular, right? Like example, as a data scientist and so on. Okay, this data, all right, generally without this data we can't do anything. But with this data, if we don't really know how to do all these things, like in the end, it's still useless. The data is just like just like a book. If nobody reads it, nobody to get the skill set and so on, right? The book is just a book. It doesn't serve the purpose. Okay. So with that, right, I wish to tell you one thing here is that normally, especially practically, right, in the industry, people are talking about this from the business to the data. It's not simply we want to collect data, we want to do anything. But the thing I hear is that we want to understand the business, right? What is the goals? What is the problem statement? Then only from there, right, we can identify what kind of data. Okay. So again, here the business here, right? What kind of goals, right? Let me directly give you to suit the today one, right? Is that, let's say example, I want to do churn analytics. Okay. Have you ever heard churn analytics? Anyone? Ladies and gentlemen? Please raise your hand or type something. No? Okay. Yeah. Churn analytics here, right, means that it's something, especially they say insurance, banking, or telco. Suppose this group of, uh, this group of customer, this group of customers, right, they are actually, they were, I should use past tense, they were my customer. But then, right, for the past 1 year, let's say example, right, they churn. That means they leave my company. They join some other, they subscribe some other services or company. They no longer loyal to my company. And to a company, this is very important because we start losing the customer. And in order to get back one equivalent customer, let's say I lose out one customer and then I get back another one customer, the equivalent cost, right, it's much higher than if I just want to keep one existing customer. This is the part. Okay, so therefore, throughout the long run, right, since the company already spent the money to facilitate, to create the facility, to create those hardware, software, human resources, and so on, support, and so on. So basically, right, what they want is the number of customer, and therefore, with that, right, definitely customer will spend something and buy something. So churn analytics is a very common business scenario or business goals and also problems are faced by every single company. Okay, so with that, right, the problem here, right, is that first I start losing my customer. I want to know. Therefore, with that, right, always we like link to two things. What are the leading factors? And can I create something like a solution or AI solution, whatever, through the problem machine learning so that it can predict one by one? Remember these two terms, which are data practically, right? I will go back to these two because relevant. What are the leading factors and what can I predict one by one? This is the part right here. Okay, so with that, right, we need to answer these two. For example, maybe somebody said that gender. Somebody said that those who complain a lot, they tend to churn. Whereas predict one by one means that okay, now I give you a list of a customer. Let's say I have 10,000 customer. Can you apply to deploy to your system already, right? Okay, this system or this whatever AI solution, right? Predict accordingly and give me a list of customer who potentially churn within next 6 months. Can you tell me? So with that, right, as a, let's say data scientist or machine learning engineer, so right, what you need to do, what you need to learn is from the data here, you start to collect the appropriate data. Then, of course, you have to do some pre-processing. Data collection, pre-processing, modeling. Normally, this modeling means all those machine learning, evaluation, and deployment. Nowadays, when talk about this deployment, generally people are talking about cloud. This is the thing. Okay, so with that, right, first you need to collect the data. When you collect the data here, right, again, your data may be raw data. So it's quite raw data. You have to change it and whatever, right? You involve all those pre-processing. You involve all those pre-processing. Then after that, only you apply the machine learning to try to predict anything, see how it does. And of course, evaluate whether your model is good enough or not. Same thing, just as students, right? I have to set up, let's say, final exam or whatever to evaluate whether you are so-called a good student or not. Okay, so that to give the grade and so on. Same to the machine. We want to evaluate the performance and give the machine, okay, whether it's a so-called class A, a very good one or very bad one and so on. Okay, if of course very bad one, which means that we cannot graduate the machine, we cannot deploy it. Same concept here. So with that, right, when we say the collection here, right, before we move on to the machine learning, right, we have to think about structured and unstructured data because the treatment will be different. For today, right, I will just touch the structured only because the structure here, right, means that those in the form of table. The unstructured data, of course, from the name you know already means that it's not structured into like a form of table. Like example, the most common one, image, text, video, audio. Indeed, my original research was more about unstructured data, whereby last time people call it signal. Signal consists of many things, okay, from the IoT signals until all this image, video, and so on. Okay. But for today, right, I will just touch this one, the structured data, whereby we want to form into the columns and rows in the form of table in this case. So how are we going to use those Pythons, codes, and so on to form all these things and then to start building our machine learning models. Okay. So with that, right, to form a table, right, what we need to have, of course, is the entire table. It can be in the CSV, whatever it is. Okay. Normally, it's actually the SQL table. Through the SQL, right, we generate the table and so on, everything, and then to pass in everything. Okay. So in this case, right, all the columns are here, right. We also call it, some people also call it variables. There are many names, features, and so on. Okay. Which is says, whereas the rows are here, right, are generally depends on what you want to do. If we are talking about the churn analytics, right, then row by row means customer by customer. That means customer. That means that in this case, a customer one, customer two, customer three, customer four, and so on. Now we start forming this already. And then here, right, are all those information like age, salary, transaction, payment type, whatsoever, one by one. So we try to consolidate, we try to aggregate the data as much as possible to get the proper columns here, a couple of columns here. Okay, because remember just now, about 5 minutes ago, I told you that we want to build this one. We want to know the leading factors. We want to predict one by one. Therefore, machine is totally plain. It's totally naive until we do something. And in order to do it right, what we need to do here is that we must create multiple columns here. These multiple columns, right now the problem is that we don't really know relatively which column or in mathematics, which variable or in data science, which feature are more helpful for us to predict, for us to understand what are the leading factors. In business, we call it factors. That's why different terms. But when we consolidate everything, right, or compile everything, right, in the end, it's just a column. But again, what are the leading? Based on the importance. Based on importance. The importance here means that from there, right, we can easily identify that who tend to churn, who tend to not churn. Maybe in the end, I can create a rules or something like this. I say that, okay, those who transacted more than $70 or ringgit and also make a complaint more than 5 times, they tend to churn. But remember that what if we have a lot of columns, we have a lot of rows, right? You want to automate the system and let the system tell us. Not really we go to view it one by one. A lot of time I hear is that people tend to like, I want to view it one by one. But this is contradicting to the machine learning. The purpose we create this machine learning is let the machine learn and machine tell us automatically instead of we doing the manually. That is the part. Okay. And I would like to highlight one thing here is that aggregation. Aggregation here means that something like because your data originally is very raw. By example, each customer, the payment it won't be just one value here. The payment type, whatever, right? The transaction won't be just one value. Salary also won't be just one value because throughout the years, their salary keep changing also, right? But what is the value you want to put it here? This process is known as aggregation. But I'm not going to discuss this too detail again. For this 2 hour, it may not be enough to discuss everything. And my target is machine learning. I just let you have this exposure for the first 1 hour as mentioned just now, so that you roughly understand how the entire picture and what to do after that. Okay, so again, reminder, this is a meant for structured data in the form of table, columns, and rows. But the very first thing is that you need to understand the business. From that, right, generally, two things you want to answer. What are the leading factors? Let's say if I don't talk about churn analytics, I talk about others Like example, I want to create a campaign. This campaign is something like a road show, okay, to attract more business and so on. So I want to know that whether my potential customer will subscribe or not. Then again, we need to go back to two things. What are the leading factors that affect them, whether they will buy or not buy our service? Second, therefore, with a one by one all the list here, right? Which customer will buy? Which customer will not buy? Can you tell me? Can you give me a list that with a very high chance that, yeah, this is the one that generally I believe about 80% of customers from this list, they are going to buy. Again, so normally we go back to these two things. Okay. So with that, this is how it does. And with that, right, whatever the pre-processing, including aggregation and so on, everything at last, we move to this one, which we call it modeling, which is the target we want to discuss here today. So basically, the modeling here, right, together with evaluation, these two actually is a come together. In the practical way, right, is that just now you already created your table. By all means, you create a lot of the potential columns. Again, we haven't really understood how so-called what are the leading factors or this thing. But at least from here, right, these are the potential one, and we want to try to identify mathematically through the machine learning method. What we need to do here, right, is that we need to form so-called in mathematics we call it. All these are the x. This is the y. The y here means there's something that the target you want to predict. Let's say example, the churn right here means churn status. Okay, so machine learning, what machine learning doing right is just is basically a modeling that relate the x to the y. But in the business world or in the so-called the human language, we call it that. Again, we summarize into two just now. What are the leading factors and one by one, right? Can you predict? Let's say which means that this customer, his age is like this, his salary is like this, his transaction is like this. He makes such complaint. He is from who? Where? Let's say he's from the Pulau Pinang. He's what and what and what. His status is yes. So now the thing is that can you create a model and predict accordingly? Second customer, same thing. Let's say he's no. Can you create a machine learning model that predict accordingly? But the very first thing, of course, is what? You must have the existing data set that you consolidate just now, aggregate, compile accordingly. From this existing or historical data, you already form into the multiple X column here and also the Y column here. So the Y column here, right, again, the reason here is that given this, then this, given this, then this. Then from here, we can apply the machine learning to tell us relatively which column are more important at affecting the churn status here and predict one by one. Next time, I give this to the machine. Can the machine predict what is that? This is the entire target. And with that, if let's say they predict, let's say the overall accuracy is 90%, and you think that, wow, this is very good, good enough already. Okay, then we can deploy it wholesale to the cloud. Okay, that is the part. But if let's say, right, the machine simply predict everything here, which is completely wrong one, the accuracy only 50%. That's better than need to do, which means that because we simply tembak, it's also about 50%, right? So which means that it doesn't help us, and therefore this machine learning, this part, right, the modeling, right, we call it cannot graduate, we cannot deploy them. So therefore, machine learning, the modeling part, right, is always together with the evaluation. We want to understand whether they predict correctly or not. Here, okay, and the problem here is that how to relate the x and the y here. Relate these two from the x to the y here. This is the part that we need to learn. We need to learn how to create this model, which is something that we are going to discuss later on. But from here, that's the part. And I would like to highlight a few things. The approach I used, right, was that just based on the, what's that, business scenario, I told you something like this. Indeed, now I need to move on a little bit more theories. First of all, if you just use the X only for the modeling without the Y, the one we call it unsupervised learning. Okay. If you use the, we call it supervised learning, that means again, these are all the machine learning models. But generally, machine learning models, right, it comes with two: unsupervised learning model and also supervised learning model. For unsupervised learning model, it only involves the X. For the supervised learning model, it involves the Y. Of course, X and Y together. This is practically how it does. Okay, theoretically, people will say unsupervised is just like the human learning. Okay, no teacher, no parents, the student learn themselves. Okay, giving the books or whatsoever, they learn themselves. That's unsupervised, right? The same concept. But to be more specifically, which means practically, right, for machine, right, we don't fix the why, which means by default, machine doesn't really know whether they churn or not, whether they buy the product or not, whether they do whatever. But based on this background like this, right, they learn something. Based on this background here, they learn something. The machine learn something and do accordingly. Okay, one of the example here is that the very common one is the segmentation, customer segmentation, for example. Customer segmentation here means that we segmentize the customer into multiple groups because that we have a couple of customers. Okay, let's say this one it can be up to let's say 100,000. Can we group them into let's say only 10 groups for to ease our management and so on? Isn't it? If not 100K already, this is very tough to so-called what's that to deal with them to so-called give the best whatever the suggestion and so on. Because this code right again, this is automated. It's not really manually. It's automated, perhaps based on the background, the example where he from, gender, age, salary, and so on. Their spending behavior and so on. Then from there, right, we can give a suitable recommender system. Okay, so the recommender system here, I believe all of you the use it before. Let's say example, Lazada, Shopee. Don't you think that the moment you enter the Lazada, they start giving you some suggestion, all these things, right? Okay, and why they know that what kind of this kind of the so-called the suggestion or recommendation, those products, anyone can make a guess why they know it. You get what I mean? Get data from other users. They read your data history. Yeah, I think the second one is more appropriate. Indeed, they read your data history. And the way they read it here is that because we ourselves as a user, the moment we subscribe, the moment we use this abstract, we already agree that we will share the data. The data can be from the demographic, like example, where are you from, your group, and so on. They understand better. And then after that, right, they also understand that, let's say, example is like your browsing history, so that whatever you browse right for the past 1 week, right, let's say for the past 1 week you generally browse something related to let's say computer, tablet, something like this, right? Then of course you can see a lot of those advertisements related to tablet, related to computer, all these things. And again, that's why this one is thanks to indeed, right, this in data science, right, this is known as recommender system. They recommend you some items that you may be interested. But because of the advertisement also, so normally we understand that they will try to recommend those that the pet who pay for the advertisement. For the similar things, those who pay for the advertisement, they have the higher chance to be published, to be recommended to you. Logical, right? But again, this one is based on the I mentioned just now, only the X. it doesn't really involve the why. Again, which means that it doesn't really directly check it whether you buy or not or whatever, but it's really just based on the whatever your browsing history and so on. Then he set a whole target for you. Okay, and also your previous expenses and so on. Okay, in order to demonstrate how this unsupervised learning work, right? For this, which is also under the machine learning part here, I wish to demonstrate a little bit here. Okay, so what I need you to do is just like this. Imagine there's a one data set. It's about people buying something. So that it has, let's say, six column, buying six different type of the items in the shopping mall. The expenses accordingly. Okay, so this is like user one, user two, user three. Let's say buy the fresh delicatessen, milk, whatever it is. So they buy something. Then until they say user 10,000 whatsoever, something like this. So from here, right, can I ask my system to predict accordingly? Therefore, that and also to sorry, in this case, is to by through the unsupervised learning model to segmentize them accordingly into, let's say, 5 different groups. 5 different groups right here. Again, the unsupervised here, right? All these one are just the X. The X here means that because I want to know their spending history. Generally, I aggregate by, let's say, per year. Okay, my member U1, right, user one, right? In terms of fresh, he bought this amount. Daily Cartesian, he bought this amount. Milk, he bought this amount. User two, he bought this amount, blah, 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 blah. Everything like this. But with that, right, about 10,000 customer. I want to group them into 5 groups whereby, let's say group one, group two, group three, group four, group five. Among the group one, they are quite similar. But compared to the rest of group, right, they are different. Example, maybe group one generally they tend to buy fresh, spend a lot of money to buy fresh. They say group two, they tend to, for every single column here, they tend to spend a little only. Let's say group three, they tend to buy lady, fuel, and whatever at a higher price. I mean, they spend more money to buy lady, milk, and so on. Then we can tailor make our business. Okay, we understand it. We can create a new campaign or whatsoever based on this. Again, there's no why here, no why, because it's not to predict anything. It's just based on the existing whatever is happening, whatever had happened, right? We try to get what the behaviors are. Okay, what are their behaviors accordingly, so that it help us to do a better business proposal. But when I talk like this, right, it's quite tough for you to imagine. So I wish you to give a try, uh, to take a look. Please go to my this personal website here. Again, you can always go to this one because it's left open 24/7. And okay. This is first. Let me send you the link. You can eventually bookmark it so that you can browse all my work there. Okay. But the one that I wish to discuss with you here, right, is this one. Again, actually, let's focus on Python because based on the feedback from the organizer a few days ago, as well as just now, right? You all have the strong experience in Python already. But more about machine learning. Okay. So doesn't matter this one I use R or Python to create, doesn't matter. But the concept is same. We can use Python to create a similar thing. It's just due to nature, I need to introduce both Python and R all the time. Okay. Right now I'm actually working with a, if you know it, Asia. Asia has a one is a Asia Academy. So normally we train those adults, working professional to deal with all this data to link to the exactly their industry problems and also the practical scenario. Okay, more practical driven basically. So here, right, the link here you can take a look. This is the one I mentioned. This data set was captured from the real data also. It has the 6 column as I mentioned just now. But here, right, I created this one and deployed to the cloud that whereby it allow us to change it accordingly. Let's say in this case, I create it to 5 groups. Okay. But before I explain this one, right, let's try to understand a bit how it does. Okay, I give you a two simple one. Let's say I only have two columns, easier, two columns. Example here is that one is a daily courtesan, another one is fresh. Customer one, customer two, customer three, customer four, and so on. They purchase differently, right? Okay, then I plot it accordingly. Lady, fresh. Customer one, he spent somewhere here. Customer two, he spent somewhere here, whatever it is. And by visualize such a way, visualizing such a way, right? Okay, logical thinking. If like this, right, if you were the machine, how many groups you will form? If they say you have a couple of customer when you plot it such a way, right? How many groups you will form here? Two, right? Yes, thank you very much. This is very fast that we can actually cut it into two. If of course this is just syntactic, right? The ideal case, very easy to observe. Even without computer, we can do it. Okay, so in this case, right, when I translate it accordingly, when I redraw it, right, I just focus on the fresh. Let's say I call this as group one, this is group two. So which means the group one, right, the expenses is somewhere around here. When I replot it, so it's between zero until a low amount, basically group one. And group two generally in terms of fresh side is from the medium until high. So it's somewhere here. Then I also try to plot another one, which is the daily. Similarly, for daily, right, daily courtesan, this one, right, also relatively good one has a lower expenses in this case. So nothing deviates much. And relatively group two, right, has a higher expenses. So in general, overall, right, we understand that for this one, it's quite significant that group one has a lower expenses for both fresh and daily. Relatively, group two has a higher one. So from here, we can easily plot it into such a way and then make a decision accordingly. So that if let's say we want to introduce any package with the more luxury items and so on, right? Then we can actually so-called target on group two, those customers from group two. Those customers from group one, right? Of course, we can target all those so-called promote something that is more affordable and so on. Mostly because of this one, right? Generally, the number of customer here is huge. Okay, we cannot lose them also. Although they are in the end, right? They really generate a lot of the so-called income for us. So this method, right, is known as a unsupervised learning, and I mark it here. So when you are interested, right, I mean, when you are free and feel interested, right, please try to browse a little bit. There are quite a number of different ways to do it. Okay, unsupervised method here. I think it's GMM and so on. Okay, there are quite a number. When probably the most common one is this K-means. Basically, right, K-means, right, how it does mathematically, right, is something I said just now. Human can observe two groups like this. So mathematically, we can also build two groups like this. But the thing is that how many groups we want to build? And here we know there is two groups. But if we decide wrongly, we put it three groups, then which means that a group, right, actually overlapping to each other. And when the column more and more and more, right, we cannot visualize such a way. Then we are facing challenging. Therefore, normally, right, we try to visualize such a way to ease the human to understand, especially when your data a lot of columns, when you want to build a lot of groups, but you don't really know how many groups. Therefore, you need to deploy the system and tell you what to do. Example here. This is the one that I wish to demonstrate. Because I can create multiple groups here. by default, I create 5 groups. Okay. And again, because there are 6 columns, right, I itemize one by one, column by column. The example is the same as here, just now here, right? Okay. If a 2 column, I can also cut it into 2 like this. So if I have 6 columns, same thing, I can separate them, split them into 6 graphs. Okay. But the thing is that how many groups I want to build. Because if a 2 column, we can visualize. 6 column, 10 columns, 100 columns, we cannot visualize already. Such a way. And therefore, we won't be able to understand. The way to do is, more appropriate way to do, right, is this one. And therefore, example is here. Also the same thing. From there, right, if you take a look at here, when I cut it into 5 groups, remember these 5 groups, right, is automatically determined by the computer through the k-means, one of the unsupervised learning. And here you can see that relatively, in this case, group 3, they tend to have a higher expenses in terms of buying fresh. Then on the other hand, right, you also can see that quite significantly, whereby this group, right, group 2, right, relatively, they tend to spend more buying grocery, milk, and detergent paper. Group 1, group 4, group 5, right, relatively less significant, which means that, oh, I set out the 5 groups here, but mostly it's a bit tough in this case, because like I said just now, based on this diagram, right, if you cut it into 2 groups, it's very good. But if you segmentize into 3 or 4 groups, right, then it's very tough already. But the thing is, if without doing all this one, right, we don't really know. All these are part under data processing, pre-processing. If we never try, we don't really know that how many groups we need to have for this unsupervised learning. Then from that, right, at least from here or through this one, or I realized that maybe I create too many groups already. Why don't I put a less? Let's say I put it to 3 groups. Okay, you can follow my step here. Just change it to 3 groups. Then you can understand better. Here, you take a look at here. Same thing. There's a one group which is now because change it to 3 groups already. Group 2, right? They spend a lot in buying fresh. Relatively, group 3, right? And also let me scroll down. Relatively, group 3, they spend more buying grocery, milk, and detergent. And group 1, they generally so-called spend less. So-called more affordable group. For everything, right, they also spend less. This is how it does. So, which means that now, if we put it into 3 groups, then we can have the 3 spatial proposal, 3 different business plan for this, dedicated for these 3 groups. First one is more affordable, everything also general. Second one specifically target on the fresh. Third one maybe it's a bundle plan, grocery, milk, and detergent. These 3, we can use these 3: grocery, milk, and detergent paper. And this group number 2 is the fresh. We can target accordingly with that. And thanks to this machine learning, imagine that if this is more than 1,000 rows and so on, right, the method is still the same. It doesn't matter already how many columns you have. You just use the same template, plot it accordingly. Okay. Again, this is just 2 hours sharing section. So if you are interested, right, indeed, you go to my GitHub. Okay. There's a one is practical R. You can take a look. Okay. I won't really discuss in detail how it does, but then you can put it here. Let me share the link as well, particularly this one. This was another topic when I introduced another, I mean, for the community service as well. Okay. Isn't there an elbow method in selecting the number KS? Yes, thank you, David. There is. You can use that as well. That is quite complicated. So we have 2 ways. The reason here is sometimes, right, That elbow method, right, is very so-called academic. When we put it into the practical scenario, right, we have to think whether it's suitable or not. Okay. By the way, in case some of you ask, right, the elbow basically is something like this. Okay, we want to get where is the turning point. It's just like the human elbow, right? Okay, the pattern. So that where is the turning point, and this turning point right, is actually the number of the K, the most suitable K, theoretically. But again, practically, right, because we want to do the business plan, right, we may can sometimes we may not afford to buy too many or to prepare too many different business plans. So again, that is a so-called dilemma between the academic theories and also a practical scenario. Okay, but David, that's very good that you know this part as well. Just like later when I discuss with you, right, the supervised learning, right, I'm going to tell you also. Theoretically, we can follow this one, but again, when we come to the practical, right, how it does. Okay, so I pause a moment here. Any question for this unsupervised? Are you all right? So far, okay. Thank you very much. So remember that unsupervised learning, right, in terms of theory or so-called what's it, the modeling, right, means that it doesn't involve Y. Y is not involved the Y column, the column Y. But from there, right, generally we try to use it for grouping purpose. Most of the time, they say customer segmentation. They say a recommender system. When we want to create a recommender system, right, we need to know you generally belong to which group, and therefore I can create a dedicated items for you. This is the part that we are trying to do that. Okay. And with that, right, I would like to move on. Okay. A good timing now. I would like to move on to supervised learning. Similarly, supervised learning, right, is still a table, but the only thing is, as mentioned just now, it has an X and Y here. So there's a Y here. So what does this Y do? Basically, again, this Y is basically you need to form it. You need to do the all this pre-processing and collect the data accordingly. Let's say just now, change status. From your existing data, there's a change status here, right? Okay, customer one. With this data set, then he churn within the 6 months. That time, right, when you jot down the data, right, then we realize that he did it churn. And this kind of data, whatever, right, he was still loyal after 6 months. He was still a customer after 6 months. So we collect one by one. We have to consolidate accordingly everything here. So this is our so-called data that we have processed accordingly. From that, right, we take a look on this Y. If this Y column, right, column Y here is a categorical variable, then we have to use something we call it classification method. If this Y is continuous variable, then we have to use regression. Again, it's quite theoretical, but here there is a major difference there between classification and regression. Let me make a special marker here. Regression basically is to find out a line to represent them or a curve to represent them. This one is to separate them. And for this one, right, normally this one again, we call it supervised learning. And supervised learning, right, basically is meant for answer the two questions I asked just now. Remember just now I say what? What are the leading factors? And then, therefore, can you predict or can your AI model predict one by one? So basically, by doing this, supervised learning models, right, we can actually get the leading factors accordingly, which columns relatively more important for business practice, okay, and predict one by one using this tool. So to give you a more general picture, right, let's say let's start with this regression, okay. But chain analytics, right? Let me ask you, what do you think? Is chain analytics classification or regression? Those who think regression, please raise your hand. Those who think classification, please raise your hand. Just a few of you. The rest, not sure. Those who are not sure, please raise your hand. Okay, yeah, quite a number of not sure, right? So which means that again, it's good to make sure that you understand this. So the Y here again, I hope that now you know what is so-called the column Y. Okay, they say here column Y, I call it churn status because our target here is to predict who will churn, who will not churn, and in general, I call it churn status. Okay, we collected this data. So with that, right, because the churn status only has a yes and no. So this one, right, we call it is a categorical variable. Categorical variable here means that it's not numerical, means non-numerical range. For those category, what's that, the column Y, right, the column Y whereby the data type is categorical, that means that we should apply a classification method. I give another scenario. They say my target here is to so-called identify what are the leading factors, and then after that also to predict one by one, student by student, what will be your CGPA before or upon graduation. What will be your final CGPA be? This is the thing I will wish to predict. So in this case, right, your CGPA is between zero by theory is let's say I call it Y, between 0 until 4. So again, in this case, right, which means that this is continuous. Your Y is continuous. Now is to predict your CGPA. Okay, based on your previous test result, based on your maybe family background, your study time, your whatever, all those paying time, activity time, and so on, everything, your background and so on, whatever. I want to predict. And from there, right, I also want to identify relatively which column are more important. Is it study time? Is it a program that you study? They say some people say that computer science is very tough. Some people say that computer science or IT. Some people say engineering is even tougher. So which one? And also, is it because whether your romance status, you have boyfriend, girlfriend, versus if you they say you don't have, which one will score better? Or not important? That is the thing we want to identify. But anyway, this is continuous. When it's continuous, we use regression. One of the most common example is linear regression. Okay, linear regression basically is that from the term we know linear means a straight line. We try to put a straight line. To ease you to ease your understanding here, right? We just put it here. The axis here they say is okay. Just now I say study time. Again, make sure that it's a regression, which means that the y that you want to do, you want to investigate is continuous. Let's say CGPA. So you have student 1, student 2, student 3, and so on. Then from here, right, you just plot into a simple graph, which I think all of you know it. Then you create a best fit curve. This is a best fit, which is I think all of you should know it. Y equals ms plus c for the easiest way. So in this case, right, what you need to do is that again the y is CGPA, and then the x is study time. You get the gradient, you get the y-intercept accordingly. But remember, this line may not be able to represent all the data correctly. Therefore, we need to evaluate. We can definitely get the m and c accordingly, but what were the out square? I leave it here. One of the very important evaluation measurement here, right, is out square. Basically, the out square is to investigate whether this best fit line is quite close to the rest of the individual data here or not. In this case, this is very important. Because if let's say your R square is very low, it's supposed between 0 until 1. If let's say, right, is approaching to 1, which means that this model is quite good. Basically, it can predict everything. You can imagine just like your score also. But if you're approaching to 0, then sorry, it's not good. And therefore, which means that although it gives you the best fit, but this best fit, right, is really not a good choice. We can't use it. Either it's due to data itself or it's due to the modeling. The data is correct, the everything is correct, but it's not such as easy as linear regression. Then we have to use some other model. Okay, there are so many models. I will introduce a bit. But again, linear regression fundamentally means we find out the straight line. And after that, people move on to multiple linear regression. In this case, right, is that why don't we give multiple X column? Again, CGPA. But this CGPA is affected by multiple column here. And then we try to plot again. Same thing. The way to use it, right? Mathematically, I call it x1, x2, x3, x4. Then from there, right, I can create my y equals mx plus c for the factor number 1 plus the mx plus, I should write nicely. Okay, let me change it. M1 x1 plus M2 x2 plus M3 x3 plus, depends on how many column you have, until plus the C. So this is how it does. No matter how, even you can build this one, the best fit curve here, you still need to use the R square. Sometimes people, the mathematician, right, they call it adjusted R square. Indeed, I should refer to adjusted R square. Okay, for more information, you can Google search what is adjusted R square. But basically, the R square here, right, in normal English, right, I call it, or layman English, right, I call it as a how close the best fit versus the individual data. Just like here. For this one, right, mostly the R square maybe is 0.9. Quite close to each other. Basically, this line can represent the data, as what I mentioned just now. It's meant for representing. Okay. On the other hand, the target we want to do. Okay, if you are interested similarly for the better learning purpose and demonstration, right? Here, right, you can go to this one, linear regression here. Try to see that this one. Play around, then you can understand better. If you don't really know which data you want to use, right, you may just download the data from here. I believe all of you can access it. Just open it. Then you should be able to do what I did explain just now. Determine the X, determine the Y, and then to right, the system will automatically calculate and give you the suggestion. But again, a lot of mathematical theories behind it here. Okay. This is because this demo is more meant for teaching, learning, and demo purpose, not really for the final deployment. So the way I did it, right, a little bit different. It's more meant for teaching and learning purpose. You can try it. And another one here, right, is I mentioned just now also, when the Y is categorical, let's say example, churn status, right, churn analytics. Normally, all these kind of the categorical, right, it form into something like this, yes or no, 1 or 0. Let's say example, if we want to classify whether a patient is COVID-19, is having COVID-19 or not. Answer is yes or no. Or people put it 1 or 0. Or sometimes computer, we call it true or false. So this method, right, is actually something relevant to categorical variable. I mean, this data set is relevant to a categorical variable, and therefore is classification. Okay, so let me tell you one thing here is that similarly, I give you a data to visualize how it does. This is, let's say, amount charge as so-called the X1. The X2 here is let's say complaint. And the Y here is the status. Let's say like this. Okay. So in this case, same thing, customer one, whatever the charge, let's say 75, 9 times, and therefore, yes. Customer two, 23, 2 times, no. Customer three, 35, 0, no. Whatever it is. Then from there, right, you plot into a graph, charge, complaint. So those yes, right, you mark it as a red color. Red color here means churn. And generally you realize it's here, sorry. Those green color here, right, means still loyal, non-churner. And generally you realize that it's somewhere here. Again, this is a so-called syntactic data for understanding purpose. So what you need to do here, right, is to try the way to separate them accordingly. One of the easiest way is draw a line like this. This method, right, to draw a clear cut like this, right, we call it SVM, support vector machine. Okay, so again, also students are here. Just want to ask, have you ever heard or used SVM before? Anyone? Daniel as well. Okay, the rest, a few of you, or David. So SVM basically means that to find out a line to give a clear cut between these two different categories, ideally. Okay, of course, again, you have many things behind, especially those who know this model, right? You know that there's a so-called, what's that, the corner trick. Just like playing football, we have the head trick. This one is corner trick. We have all those, what's that, the C level regularization, sorry, regularizer. So all this case, right, is just if you're interested, you can browse more. Okay, the C value corner trick. And here I just put it to let you know so that you can continue to browse it about this one. But SVN is definitely one of the very popular methods that we try to, we can use it, provided if they say there is really a very significant clear cut. Another method is that we call it KNN. Again, based on the K. K here means integer, just like just how the K means, right, also integer. And there's a problem here is that which K is the most appropriate one. Just like just now, by theory, we can use elbow. And here, we can use some other mathematical theories to support. But let me tell you, in the reality, right, the best way is that, especially for classification, right, is that if you evaluate the outcome and it gives you the best accuracy, that is the one that you should focus on. Same thing, right? Just like there are so many ways to study, but as long as you can really study within the short time and then can score it, that is the best method for you. Hey, by the way, any question is it? Okay. Doesn't logistic regression also work for classification? Yes, it's also working. But give me some time. Another 5 minutes, I will introduce that. Okay. I'm going to introduce about 4 or 5 methods because if you take a look on my this one, right, I have a few methods here also. KNN, SVN. I just now I touched SVN already, right? Now KNN. Then after that, logistic, and so on. Okay, David? Definitely you have the experience, so you already know all these things. That's good. So KNN here, right? The name here, this one is known as a nearest neighbors. The analogy here is very simple. Again, machine learning is just a human learning. And the nearest neighbors here, right, is just a very simple, just like it copy humans theory also, whereby if let's say I'm a lazy guy, I want to buy a car, for example, Toyota or Honda, let's say example, or Proton Perodua, BMW, Mercedes-Benz, whatever. So I just go to ask my nearest neighbors, hello, hello, uncle, what do you want to buy? If you were me, you want to buy a car, Proton, Perodua, Honda, Toyota. That's it. I don't really make my own judgment. I don't really make my own research. Just ask my friends, ask my nearest neighbors, get it. Okay. So for the machine learning here, right, the KNN also uses a similar concept. The way just now, remember I draw it just now, right? Okay, somewhere. Okay, now they say I zoom in already. Okay, generally, suppose generally those channel around here, a few are here. Generally, those lawyer, a few are here, majority are here. So right now, right, if I have a new data, I want to predict who this guy will be, whether he will be churning or he will be a loyal customer within the next 6 months. In the next 6 months, then I try to check relatively what is the his current complaint and also expand what's it the charge and so on. So he's somewhere here. Relatively, his data is somewhere here. And if they say the K here, right, I set it to let's say 10, for example. Okay. So which means that you will try to find out the nearest 10 somewhere here and see how many of them belong to lawyer, how many of them belong to churner. So in this case, right, 8 belong to churner, 2 belong to lawyer. So we will make a conclusion, or the this KN will make a conclusion. This data, this customer will be a churner. This is how it does KNN. Just ask neighbors, and therefore some people also call it lazy model. Again, if you go to browser in depth, right, there is a so-called weighted and so on, how they calculate the distance here and there. There are many so-called advanced mathematical models in both. But no matter how, this is fundamentally how it does. Okay. And with that, I think you can also see that always I mention something, we call it test. And all the data here, trend. So from here, allow me to introduce you a little bit more in depth regarding this machine learning so you understand better. In general, right, if you have any table that is already, you have your X already, you have your Y already, right? Let us try to split them. The entire process, we call it trend, test, split. This trend test split basically is to cut them into 80%, 20%. But I put it randomly, which means it's not really top 80%, bottom. It's randomly. We so-called shuffle it randomly, 80%, 20%, split them so that this is so-called a training set, and this is so-called a testing set. The analogy is still similar. For human, right, of course, let's say as a lecturer, right, we give you those tutorials with answers for you to view it, to teach you whatsoever. This is supervised learning. And then after that, right, you will be attending a final exam. The final exam tests you. This one, no training mode. This one just tests you and you predict accordingly, you answer accordingly. As a teacher or as a lecturer, will mark it accordingly. So the same concept here. Whatever the model we use just now, right? We just use the data here. We just use this one, whatever just now I say KNN, SVM, David mentioned about logistic, whatever it is. Then later on, there's a random folders, there's a deep learning, whatever. Basically, we just use this 80% of data. Computer never see this 20%. So to be more specifically, I call this as X trend, this is as Y trend. Then this is a X test, this is Y test. Again, this data set right now, right, every one of you, right, is a lecturer. The machine is your student. You want to train your student well. And therefore, this is like the so-called testing set, like I said just now, it's like a final exam. This is the question. This is the answer. Remember, this one you don't pass to the computer. You only pass the computer this one for the training purpose. Computer try to use KNN, SVM, and so on to learn how this looks like, to establish between the X and Y, which I mentioned just now, right? Let's say example, KNN, we use this method. There's a X, there's a Y. That's why we can plot accordingly, which means that this one is only a training set. Same as a SVM just now. We draw a clear cut here, right? This whole thing, the whole data set here, right, belong to training set. Let me mark it also here. It's a training set. So that from this training set, we know the Y component, yes or no, all these things. The computer knows it. They plot it accordingly. They get the best fit line to separate. Okay. Then after that, we have this 20% as a testing. We don't disclose this one. We ask the computer to predict accordingly. Okay, since you know it already, now give you this one. Can you predict this one? Give you this one. Can you predict this one? Computer never see before. And if computer can answer it accordingly, well done. Which means that we can deploy it. We can graduate the computer, the machine. This is how it does. And that is the thing. Trying to speak here. Okay, so with that, again, this is a general how the picture looks like for the KNN. Okay, I pause a moment here. Until now, any question before I move on to the logistic equation? Okay, if until now you think you're so far so good, please raise your hand. Okay, oh, this is quite a lot. That's good. Thank you very much. Okay, then I continue to discuss logistic regression. This logistic regression, I remember, is extended from linear regression. Remember just now we linear regression I discussed with you. We talk about what's that regression. This logistic regression, although the name is regression, but it's extended from this linear regression and it becomes a classification. To give the scenario, right, I will try to discuss with you just now what we did. Remember linear regression, we were talking about the student result, right? So why don't we use that as an example? But now instead of result, I use grade, pass or fail, study time. Similarly, this must be from the training set that I mentioned just now. 80%, of course, 80% is just rule of thumb. It can be 85%, it can be 75, doesn't matter. Okay, there's no fixed rule. This is just rule of thumb. Then here, right, training set, okay, we jot down one by one. There's an X, there's a Y here, we jot down one by one. Similarly, through the logistic regression, internally, the computer will try to compute accordingly. Plot the graph, study time. The grade, pass, fail, 1 and 0, right? Some student pass, some student fail, as usual. Then we plot it accordingly. Generally, we realize that those who study a lot, majority pass a lot. Okay, logical thinking, right? Unfortunately, somehow some students study a lot, but they still fail. This is really quite question. And we also realize that those who never study or study just a bit, they generally fail. But they are genius. They are so-called what's it, very good. What's it? They don't even need to study. They still pass. But not many. So if you use a linear regression, of course you plot a straight line like this. But in this case, right, it becomes irrelevant. Basically, the logistic regression, right, is changing the graph from the linear like this, right, become a S curve. So the best fit curve in this case, right, is no longer linear, but it's an S curve like this. Ideally, this is 1, this is 0, right? Simple probability, that means there's a 0.5 cut 9. So more than 0.5 means 1. So what is the corresponding here? Let's say if this is 3.8, then the full rule here is if the study time greater than 3.8, pass. Smaller than 3.8, fail. This is the part that we are trying to establish. Thanks to this logistic regression, that there's a lot of again those logic function and so on. If you're interested, please feel free to browse it. Okay, but this is fundamentally how it works. And also there is a so-called calibration here, not necessarily 0.5. It can be 0.4, 0. Whatever. If you're interested, please feel free to browse it as well. Okay. Then this is the part. Then if I have any testing data set, right, like just now, right? So the testing set, let's say in this case, right? In this case, the study time here is 2.1. So based on these rules right here, since it's 2.1, right, then I will predict, or the logistic regression here, right, will predict the student field. Again, for all this model, we have to check whether they evaluate. We have to evaluate or to check it whether the answer is predict accordingly or not, correctly or not, accurately or not. So in this case, right, we have to check one by one. Okay. I think this one not enough. I will just close it, and then I use another one. Whiteboard. Okay. Remember just now I said that there is also called the actual grade. Indeed, right, in the data science, they also call it Y test. There's a Y predict. That means it's the predicted grade. So some student pass, some student fail as usual. There are 4 scenarios. These 2 good one, they predict accordingly. These 2 not good, they can't predict accordingly, isn't it? Either they pass and predict pass. So in this case, right, with that, we form in terms of number because there are so many, as a we call it confusion matrix. So again, in mathematics, right, they call it confusion matrix because let me share this one. I send the link to you. Why is it so confusing? Because if you take a look, right, tons of formula just from the simple 2 times 2 matrix or table. There are so many formulas here. If let's say we want to fill a student, right, we ask this one without giving the formula list, I think mostly the student will fill. But I think it's unfair. Okay, because practically when we go working right out, right, we don't really need to memorize all this, but instead we need to know how to use. Okay, so in general, what it has, right, is just to do a comparison. This confusion matrix right here, right, is just to do a comparison. Remember, confusion matrix, right, is only for classification. Because classification is here, right, whatever you predict, right, is either 1 or 0. Yes or no. That's it. Okay, it's not the rest. It's always either 1 or 0. So in this case, right, what we have is there's a Y actual. Let's say just now, great pass or fail, right? There's a Y, this is what they say predict. So generally we put it 0 and 1. And normally the 1 is the most important one. Let's say now we talk about to use this as a scenario, we call it about churn status. 1 means churn, 0 means loyal. And the target we want to have is to double check the 1. Okay. And in the testing set I mentioned just now, let's say there are 1,000 customer in the testing set. 600 customer whereby they really churn, system predict the churn. Let's say this is just a synthetic data. So out of this 1,000 customer in the testing set, which means the computer never see before during the training, during the modeling just now, they only what's at the computer, then this testing set is used for computer to predict only. So in this case, computer predict 750, in total 750 as loyal, 250 as churn. But in the reality, 650 loyal, 350 churn. So to be more specifically, which means that this no good, this no good, this good, this good. Because computer is able to predict accordingly. Computer is unable to predict accordingly for this. Which means that 150 cases whereby, or customer whereby they really churn, computer predict not churn. No good one. This one also no good. They are loyal, computer predict as churn. So later when you give a list, normally you give this list. You give this list, hello boss, out of this 1,000 customer, my AI system predict 250. So in this case, from here, you can roughly imagine for every 250 customer that you give to your boss, right, say that there would be churning, 200 are correctly predicted, 50 not really. On the other hand, you miss out 150. That is the meaning. From this confusion matrix, we can see what for every 250 customer that you predict they will churn, 200 are predicted correctly, 50 not really. And on the other hand, 150 actually you miss out, which means that this 150, right, they will really churn. For the business scenario, is not good. But of course, everything comes with percentage between 0 and 1. Like just now, the R square also 0 and 1. We want to understand in overall. Okay, and also specifically. So what normally people do, right, or people do, right, only 3 things: accuracy, precision, and recall. Okay, accuracy is very simple. Overall only. So in this case, right, overall, out of 1,000, system is able to predict 800. Okay, 800 what? Doesn't matter 0 or 1, as long as you predict overall. So that is 0.8 or 80%. Looks like very good. 80% score A already. Let's take a look on the precision. Precision, PRE, is referred to predict. So that's why I use this whiteboard, because you can see whatever I scribble, then you can understand. And it doesn't follow the so-called long tracker, whatever the slideshow and so on, because this is just 2 hours so-called squeeze workshop. So based on the predictor here, right, which means that it predict 250, system is able to get 200 correctly. So this percentage is also about 80%. Also not bad. Okay, out of 250, 200 are correctly predicted. The problem is recall. Recall is RE, refer to the reality. In the real case, right, 350, system managed to get 200. That is about 60%. So you look at here. Again, recall is referred to reality. And the reality means that what is actually happening. And normally we target on 1. Because 1 is something we want to target for or target on. So in this case, right, 350 customer, they really churn. System only able to predict 200. That is mm, about 60%, I guess. So 60% is not a very fancy in this case. As what I said just now, which means that you can see this as a, excuse me, with this one, right, is another so-called reference. This is more for mathematics. This is more for general picture. Similarly, which means for every 1,000 customer you predict that will churn, right, you can get the 800 customer correctly. You also miss out 600 additionally times 4. Or you use this as a reference. Relatively, the recoil here, right, is not fancy, and you really miss out this customer. By theory, again, there is a so-called true positive, true negative, type 1, type 2, and so on, everything. ROC curve and so on. That is a, if you're interested, feel free to talk to me afterwards. I can discuss with you, or else, right? Of course, you can study it. There are so many materials there as well. My, this, what's it, practical here, right? Also has it, everything. All the things, precision, recall. Okay. So with that, this is how it does. Doesn't matter which method you are using. Generally, in the end, right, is that based on the method, based on the model, you get the predict accordingly, form into the confusion matrix, get the entire classification report together with the accuracy, precision, and recall. That is how it does. And of course, a quick recap just now, we study SPM, logistic regression as well, KNN. So now, right, perhaps it's good I introduce, okay, we call it decision tree. And from this decision tree, we move on to the random forest. Okay, and to be honest, let me tell you, mostly, right, especially for the business analytics, right, this is gonna be a very good choice. For today here, right, I'm not going to touch deep learning because due to the time constraint, and deep learning is very huge, and some more deep learning is mostly for unstructured data. Normally, business analytics, right, it involves structured data. Okay, but if you're interested, right, again, never stop learning. Here, right, I have quite a number of different demo here also, like AI chatbot, AI for fun. All these are meant for the unstructured data, face recognition, and you can take a look how it does. And also, all the code, right, is also in my GitHub as well. You can try to observe it how it does. Thanks to Python, actually, the code, right, is not lengthy. It's really very short. Okay. So now let us discuss this one, the decision tree. So I will use back something we discussed just now, the chain analytics, right? So I try to put like this. Remember just now we use what? Complaint, charge. And again, this is referred to the training set. So this 80% training set, we plot it accordingly. Let's say this round, right, the graph, it looks like this. Generally, the channel around here. Around here. A little bit here. Generally, majority of the lawyer around here. A little bit here. Some of them here, not many. So from here, right, what decision tree is doing, right, is that just like the SVM, but it will just draw a couple of horizontal and vertical lines. So it spread at its best effort. But we should, in terms of visualization, we can easily do it. But in terms of mathematics, right, of course, you need to use some formula, which is normally, like example, entropy, information gain, all those, what's that, the Gini index, and so on. If you're interested to know how they split the horizon into left and right, up and down. Okay. But for demo purpose here, they say put it 7. So the very first thing here, right, you would try to put it complaint greater than 7. Yes or no. So among the yes, right, which means it's here, And among this one, right, I think we cannot further split it because it already reached a very so-called what's that, significant scenario here, whereby in this case, let's say 93% churn. This is the final conclusion we can make already. Then we try to check no. No here means smaller. No here means this smaller one. So here, right, maybe it's not significant yet because here, right, maybe in terms of churn, right, 40% churn. So which means that 40% chance, right, there is a still very high chance, I mean, that to get a wrong one. So in the case, right, what we need to do, right, is we further split them if possible. So in this case, we split them, computer split it accordingly somewhere here. Let's say this charge is 75. So now, among those component less than 7, how about the charge? Is the charge greater than 75? Yes or no? For the yes, which means this group, let's say this group, right, 80%, 85% churn, for example. And let's say no, right, 5% churn. So in the end, we managed to get this. Again, this is just a syntactic data, very so-called idealistic. But indeed, right, in the real scenario, right, we have to create a lot of groups to get all these things, to check it out, how it does. Okay, so this one is known as a decision tree. Basically, it make something like a pyramid like this, and they call it this as a tree, this pyramid diagram as a tree. And because from there, right, they have a couple of rule-based decision. That's why overall they call it decision tree. And this is how it does. So therefore, decision tree here, right, from here you can see that out of so many columns, right, it will try to find out the best columns for us with this or this thing, and it can summarize into as a percentage, normalize it into percentage. So decision tree here, right, it managed to tell us the feature importance relatively, which column are more important. It can predict one by one. Now I link back to what I mentioned earlier of the day today. Always for the business analytics, we want to target this too, right? What are the leading factors? But for data science, right here, we call it the feature importance. Second, can you predict one by one? Answer is yes, by giving you just now all those whatever the recall, precision, and accuracy for the classification. And that's the reason why decision tree and subsequently all those tree based models, right, are so popular for business analytics. Okay, so from this decision tree, we move to random forest. Because there was always a classical joke, right? They say that why because of one tree you forget entire forest. Okay, so this is the part. For the machine learning, also the same thing. They say that why because of one tree you give a because an individual tree somehow sometimes may be biased. Who knows? Mathematics always worry about bias, right? Out of sudden, also even human the same thing. We hope that our parent won't be biased. Maybe treat better. They say for elder brother treat better, for younger sister treat the bad or worse or whatever. We don't want that also. So in this case, random for us, the name already says random. So basically, create multiple tree here. Then do a voting. Just like what's that? We select government, right? We do a voting also. So if let's say here, right, for this data set, it's true. Majority of the trees say that yes, I predict each one. Then, which means that in the end, we will say that this is churn. Compared to just a single decision tree, this is much better. Normally, random forests I tend to give and the random forests here, right, there are a couple of parameters for you to choose. Most important is the number of trees. Number of trees are here because you can choose 5, 10, 100,000. Then you see how it adjusts accordingly. Okay, so with that, right, I would like to demo, but again, same thing here. I pause a moment. Any question here? I would like to demo this one, then you have a better picture. And again, this one was developed using Python. You can go to this machine learning with scikit-learn right here. Take a look. If due to the time constraint, right, I don't discuss the Python in details, and that's the reason why morning just now I asked you whether you all understand Python or not. If you understand Python, right, I believe you can go through, you can already understand what I wrote all these things. The coding is very simple, but you can see also is thanks to the OOP. All the way the how the Python we wrote the Python here, right, is based on the Python OOP. Okay, if you have already prior experience in Python and also the OOP, right, you should be very quickly to capture all these things nicely. Okay, well that's why I emphasize the machine learning part more. Then you just go to the link here. What you need to do, right, is that now we can move on to this user define. Again, this is meant for the demo purpose. And here I set default data set and also user define, but I would like you to just go to user define and then write oh yeah, I should share this first just now. Please download this data set. Let me copy and paste. I think you don't have this data set. You just download this data set. It's a CSV, but indeed here I also copy it. It's just this one I already upload to this GitHub. But to issue, you just directly download from the Google Drive easier. Okay, what I need you to do is just upload the file accordingly and observe it. So this one I built it for the demo purpose all these things to see and also to like so-called let the student understand. In the end, right, even here, right, it's more like a understanding, okay, the source code of this thing. We still need to deploy it so that to complete the entire cycle. If not, right, it's like, just hang out sudden, nothing much. Okay, so you just browse it. Oh, sorry, too many files. Just a while. Okay, suppose once you have uploaded the channel here CSV like this, right? So you can see that my system is able to automatically ask you to put X and Y accordingly. The Y here, of course, for this data set, let's go to take a look at what this data set is all about. When you open the link, right, you should be able to see something like this, isn't it? And just now I asked you try to okay. So this data set I asked you try to download, right? Okay, you can see here there's a state, different multiple, but again, we don't really know which column are more important one. Okay, voice plan, whether they subscribe to fixed voice plan or not, internet plan, in terms of number of whatever messengers and so on, everything. Okay. On the other hand, if from this GitHub here, right, you can also see the data set is here. This one. I also uploaded to the GitHub. You can play around as well. Okay. So what we need to do, right? Once we get it right, let us investigate a little bit. So first of all, the Y here, right, we adjust it to label. Label column, right, it consists of true and false. Then we try to take a look at the classification report here, number 3. Focus on this overall accuracy, which means that in this case, right now is 80%. And also this one, precision and recall for class 1, 10% and 2% completely out. That's why overall accuracy sometimes give us a misleading info. 82 sounds good, A already what. But when you take a look on this precision and recall, 10%, 2%, which means that for those the real channels, right, system only can ever to predict 2%. Cannot, right? This one, whatever system predict, right? Out of 100 customer, only 10 are the real churner. Also cannot. But of course, we haven't done all the things here, right? We need to set up a little bit, configure it accordingly. So in this case, follow me, the classifier here, you change it to random forest. Okay, change it to random forest. This one, the depth, right? You can adjust it to something between 12 to 15. This one, you can drag it to 100. Let me drag it and then I pause a moment. Okay, what is this? This maximum depth, remember just now, if they say the splitting is not good, right, it will continue to split until how many levels you allow? Up to. Whereas this one, right, is number of trees that I mentioned just now. How many trees you want to give? So let's say I give it 100 trees. Okay, once you're okay, right, now let's try to take a look. This one, the X, right, let us adjust it, add column by column. Okay, let us add a few. You may just add it accordingly. The system will do it the rest. Okay, I try to add a few. You can start seeing that, especially this one, start changing, and we try to check until we get try your best, try to see at least more than 75% for the recall class 1. Again, the class 1 here means the churn, and the rest, right, more than 90% for precision, for accuracy. We try to check it everything. So try and error. We try it to put it everything. Remember, level is for y, therefore the x side we don't put it. Okay. So we try to put more and more. You can see now increase to 44% already for my one. Oh, okay, let me adjust it. Yeah, you can see. Now when I put at this, right, you please feel free to try and error. So which means all these are the columns I'm using. And then after that, right, by putting this one and this one, I managed to get 83%. And the rest all 90 something approaching to 100%. So which means that it's quite clear that for this data set, again, this data set is a real data set provided by someone through the Kaggle. So if you want to get what's that, the machine learning, right, it's really strongly suggested you to try the Kaggle. Okay. So here, right, you can see that by putting this, which means the next time, right, as long as there's a new customer from the same company with all this data, whatever, right, I can actually ask my system this one to predict accordingly, and then so it managed to give 83% for the recall class 1, and the rest all 90 something percent. We can easily see it from here. Okay, so this is thanks to this random forest. Remember, I set it to random forest. Okay, those are managed to try this hands-on. Please raise your hand. Okay, thank you very much. Please put down. I think still maybe a couple of you, right? Okay. Again, if let's say you feel lost or whatever, right, you can still talk to me personally. We have some individual discussion and so on. Okay, or else browse it. Okay. And the last part of today here, right, another maybe just 5 minutes to let you know the about this coding. Okay, the Python one you can go through. Most important here, right, you can see, like I say just now, the entire Python code, the library that we use, right, is we call it scikit-learn. Okay, this one, sklearn. So you just what's it? Python's scikit-learn. So I use this scikit-learn to build the entire machine learning here. And you may want to ask that how about those like TensorFlow whatsoever? Remember the one is meant for deep learning, which is normally meant for those unstructured data. There is a different treatment. But for all these structured data, right, mostly scikit-learn really provide a very good machine learning libraries and also as well as those models, everything with the bombastic coding. But now it's just a few nights we can do all the rest. Which if you follow the steps here, right, you can easily see KNN, SVM, logistic regression, naive Bayes, random forest. But in the end, right, because random forest managed to give me the best answer, that's why I continue using random forest. And therefore, the entire visualization, that's what I hear, right, just now. I use this one to demonstrate. Okay, so today, if you are free, please feel free to browse all the Python code here and anything, right, you talk to me later on. What are the leading factors here? Okay, so you can see that the random forest, right, managed to give us the feature importance in terms of percentage. Then I use some code here, right, to make it to become a full table that is sorted accordingly. So relatively, not to be too surprising, the charge NCSC is a number of customer service call, but that is actually number of complaint. This is a number of minute, and this number of minute actually contribute to the charge. So basically, in the end, right, charge money matter as well as number of complaint. But of course, we have to understand better. Okay, in this case, right, let's say number of complaint that we know already. But the next question is then, can you summarize for me what are the complaints that people build? What are the comments they gave? Isn't it? People that complain whatever, right? They text you, they email you whatsoever. Can you consolidate everything? But again, it may be more than 1,000 or 10,000 and so on. And therefore, it deal with text analytics beyond our discussion today. But basically, let me tell you, this is unstructured. And to do so, right, basically, we have to use deep learning. The name already deep. Deep learning is part of machine learning, but it's deep. Okay, so it has some deep. Again, follow humans because human has a deep learning education also. How you all learn things deeply. So same to machine learning as well. So the text analytics are here. Together we call it sentiment. Okay, if you want to have the greater picture about this, right, although we don't discuss that, right, you can also feel free to go to, I think this one, either the AI chatbot to understand a bit, or else there's another one is the this one web clothing. Okay, David, TensorFlow take about 1 day and 10 GB to install. Don't worry. Okay, if you take a look at here, right? Okay, let me show you. Indeed, you don't need to install anything even for learning purpose, even TensorFlow and so on. Because when you come here, right, what you need to do is just, okay, and just now I also, this one Colab. All you need to do is just open in Colab. This one you click it, okay. In case I was too fast, right? Just now the link provided to you, right? The very beginning, there's already this symbol. Just open it accordingly. Click it. Okay, so you're gonna see this one. And remember, this is under GNU open source license, because I prepare and I put it as a open source license. Okay. Then in this case, right, what you need to do, right, is just create a file, save a copy in Drive. So your Google Drive, right, going to have this collab version. And although at here I don't really use any TensorFlow and so on deep learning, but indeed, let me tell you, since it's also by Google, Google Colab support TensorFlow very, very, very well. And this entire collab, right, it allows you, again, you all have already the collab, I mean the Python experience, right? Once you connect it, right, you're gonna see that the RAM memory given for you, right, for free by Google Collab is about 12 gig, if not mistaken, just to run this only, excluding the rest, just to run this 12 gig RAM provided for you for free. On the other hand, if you check the runtime here, right, indeed, you can use GPU and TPU to run the deep learning also for free. So I think this is very good. So again, we don't need to install anything. Just put the TensorFlow here. If you are interested, you just search TensorFlow collab or whatever. Then there are a lot. Let me type something. Yeah. Eventually, this is by Google Colab itself. It provide you this as well. Okay. So then nowadays, especially because for all these training classes and so on, generally virtual class, right? We cannot set out all those computer facility, right? So we have to use this online. Entire Google Cloud is actually hosted on the entire Google Colab, right? Is hosted on the entire Google Cloud. But then it's built such a way you can play around. And the concept is still similar here. It's just that it's a different users class and so on. But again, there's a training set, there's a testing set, and you have to evaluate. So it will be good if you understand the fundamental machine learning, what it is all about, and then for the TensorFlow, right, it's considered deep, and you use it again. Then you can play around. Okay, I think with that the timing is good here, so that David, yeah, that's unfortunately yes true. Whenever you use a collab, right, then you need to install because although it provide free, since it provide free, as you said, since it provide free, right, it will always so-called refresh it after, if not mistaken, 12 to 24 hours. Once you become idle and you never use it, right, after 12 hours, it will be refreshed to the original state. So if you have any additional library, right, you have to put it and run again. So therefore, it's not meant for deployment. It's meant for testing, learning, everything. Everything all right. Once you want to deploy, you deploy to the cloud. Make it as like a web page. People can click the web page, open, and check your work. That's what I presented just now. Okay. So to the rest also, any questions here before I officially stop it? We can still have the informal discussion, no worry. And David, if you are interested to talk, right, we also can talk about the more advanced work as well. Okay, I believe again you have a sufficient fundamental skill set. Okay, so with that, thank you everyone. I pass back to the organizer. Thank you. Hi, is organizer here?
So I was muted. So
Okay.
yeah, hi. Thank you so much, Dr. Young, and thank you everyone for joining us today, the day after Christmas. And thank you for staying with us till the end. I believe that was quite insightful. And there's also the notebook that Dr. Young shared on GitHub. So guys, go check that out after this and run it yourself from Google Colab, I guess. So once again, thank you everyone for coming, and especially thank you Dr. Young for taking his time on a Sunday morning. From He's not in KL, he's in Kampong. Even still, he took the time to teach us today. So thank you so much for that. We recorded everything. We will be sharing the recordings on the DSC YouTube channel a bit after this, exclusively for participants only. So we will share the link on the event Discord server once everything is over. In a few hours, there will be a event survey form sent to you to fill up a short survey about how the event went and how we as the organizers can improve. And also, please continue supporting the SCMU with other future events that we have coming up. So thank you so much. A belated Merry Christmas and advance Happy New Year. Thank you for joining us today.
Okay, thank you everyone. Feel free to talk to me if you have any other questions and so on. Uh, how should I pronounce your name? Marvin, is it? Yes, that one right. I use Heroku because for the lightweight, but for the heavyweight, like the commercial and then the enterprise, right? Maybe the those like Google, Microsoft, and so on, right? Will be a better choice. Okay. If no more question, I will leave this room, and you can still connect me to via LinkedIn. Okay, everyone. Thank you. Happy weekend.
Where can we get your contact?
Do you have a LinkedIn?
I have a LinkedIn, although I need an easier way to access you.
You can link it from there, right? You can also, if they say you want to have Facebook, right? Just search my name. I just use my name Yong Poh Yu. You can easily search it, and then there's the so-called my profile there. Then you can easily add me. Is that all right, David?
Yeah, no sure.
Yeah. Okay. Okay. Yeah. Then thank you. Okay. Bye.